Did you know that electric cars were made first? In the year 1900s, if you walked past a car on an American street, there was a better chance it was electric than gas-powered. Census records from that year show electric cars made up around 38% of all vehicles in the country. Gasoline cars trailed behind at roughly 20%. The best-selling car in America in 1900 wasn't a gas guzzler at all. It was electric. Then, in less than 2 decades, electric cars nearly vanished completely, and gasoline took over the entire industry for the next 100 years. So what actually changed? And now that electric cars have quietly clawed their way back to the top, how do these things actually work under the hood? Because the answer is stranger and simpler than most people assume. Back in 1900, electric cars had real advantages. They didn't need to be hand-cranked to start, unlike early gasoline engines, which could violently kick back and break an arm if you cranked them wrong. They didn't smell, didn't require gear shifting, and didn't take 45 minutes to warm up the way early steam cars did. Their one real weakness was range. Then, in 1908, Ford's Model T made gasoline cars dramatically cheaper to mass produce, and in 1912, the invention of the electric starter finally solved gasoline's dangerous hand crank problem. Combined with cheap, widely available gasoline, the advantage flipped almost overnight, and electric cars spent the next century as a footnote. Fast forward to today, and the technology powering an electric car is almost embarrassingly simple compared to what it replaced. A gasoline engine is a small controlled explosion machine built from well over 1,000 precisely timed moving parts, pistons, valves, camshafts, all synchronized to detonate fuel thousands of times per minute without tearing itself apart. An electric motor does the same job, moving a car forward. With as few as 20 moving parts total, there's no combustion happening anywhere. Just electromagnetism. Electricity flowing through coils, creating a magnetic field that spins a rotor, converting electrical energy directly into motion. That simplicity creates a strange side effect most new EV owners aren't ready for: instant torque. A gasoline engine needs to rev up before it produces peak power, which is why traditional cars need multiple gears to stay in their ideal power range. An electric motor doesn't have that problem at all. It can deliver its maximum torque instantly, the moment the car starts moving, from a dead stop. That's why even a modestly powered electric car can feel shockingly fast off the line. And it's also why most electric cars don't need a traditional multi-speed transmission at all. One gear is usually enough. Braking works backwards too, in a genuinely clever way. In a gas car, braking is pure waste. Friction pads grinding against discs, converting the car's motion into heat that just disappears into the air. Electric cars use something called regenerative braking instead, where the exact same motor that propels the car forward temporarily reverses its job and acts as a generator. As the wheels slow the car down, they spin the motor instead of the motor spinning the wheels, and that motion gets converted back into electricity, flowing straight back into the battery. The car is quite literally recapturing energy it would have otherwise thrown away as heat every single time you slow down. That efficiency shows up in an even bigger number. A typical gasoline engine only converts around 20 to 30% of the energy stored in fuel into actual forward motion. The rest is lost as heat and noise, wasted the moment you turn the key. Electric motors typically convert somewhere between 85 and 90% of stored electricity directly into motion, It's the difference between a machine that wastes most of its fuel and one that barely wastes any of it at all. None of this happens through one giant battery either. Inside a typical electric car battery pack are thousands of individual battery cells, similar in basic chemistry to what's inside a laptop or phone, wired together and constantly monitored by a system that balances the charge across every cell, keeping the pack safe and efficient for years of daily use. So the next time someone tells you electric cars are some brand new, unproven technology, you can tell them the truth. They were here first. They briefly lost the race for 100 years. And the machine that eventually replaced the gas engine turned out to be radically simpler than the one it was up against the entire time. If this changed how you think about the car you might be driving right now, hit that like button and subscribe if you're not already so you don't miss the next one. Let me know in the comments. Did you know electric cars actually came before gas cars dominated the roads? See you in the next video.